My name is Brian Richard, and my student research is titled Chewing with Psychophases is Ancestral to Gnathostomes. Chewing is a critical task for most vertebrate species. Mechanically separating food into smaller pieces makes swallowing easier and aids in digestion. Phasic chew cycles in mammals start and end with the mouth fully open, where gape distances graft over time. The four phases of a chew cycle are the fast close, slow open, and fast open phase. Reasons for chewing with phases include increased precision to prevent injury to dentition or soft tissue. It also introduces an element of rhythmicity, which increases the energetic efficiency of chewing by operating with the natural pendulum frequency of the jaw motion. Because phasic chewing has been observed in non-mammals, we asked, are mammals and bony fish the only taxa that have multiphasic chew cycles? Here we see an ocelot river stingray chewing in repetitive cycles, and here's an axolotl doing the same thing, albeit with far less frequency. Yum! Following our observations, we hypothesized that anamniotes would exhibit multiphasic chewing as well. Our method was to implant specimens with beads and use X-ray reconstruction of moving morphology to track the gape distance over time. Using the first-order derivative of the gape, we used changes in velocities to determine the four phases and extract durations and velocities of each phase. Then cycle phases were compared to two-tailed paired t-tests. Based on the results, 3 new patterns of multiphasic chewing were observed. In these box and whisker plots, the velocities of the phases on the y-axis are plotted by the four phases on the x-axis. Statistical significance between the phases indicates that they are distinct from each other. Starting with the most basal species, we observe chew cycles with at least 3 phases, including here in the ocelot river stingray and here in the bakir. We saw 4 cycle phases in the more derived African lungfish, and following the fish tetrapod split, axolotls chew with 4 phases as well. The second pattern that we see different from mammalian chewing is high variability in the first phase, which would be the fast close in mammals. They partition all their high variability into the fast open phase. Moving further down the fish tetrapod split, we saw a third pattern of phasic chew cycles. Whether feeding aquatically or terrestrially, there is no statistical significance, suggesting the crested newt seems to abandon multiphasic chewing for biphasic opening and closing only. What should be the second phase, or slow close power stroke in mammals, is faster than the newt's first chew phase. This may be due to the unique nature of the newt, spending half the year living in the water and the other half on land. Our results extend the origin of multiphasic chew cycles closer to the base of gnathostome phylogeny, indicating that this feeding pattern may be basal to jawed vertebrates. It is a complicated evolutionary history involving speed and cycle phase changes, leaving unclear the implications on the evolution of injury prevention and energetic efficiency. My future studies will include more basal fish, rays, and sharks, as well as investigating aquatic versus terrestrial feeding patterns. I would just like to thank you. And I can't say that I couldn't have done it without my many collaborators in the Konow Labs aquatics team.